I'll be presenting today a platform that we have been working on for the last few years, aiming at federating the tools and infrastructures of data science into one consistent framework that makes the access to data, the access to technical computing environments, and the access to cloud computing infrastructures as seamless as it could be. So we have rebranded from ElasticR to RosettaHub in order to maybe reduce the R connection that we started with, but ended up having something that is completely generic, where Python is a first-class citizen as R is. So I will have demos. I think there is an issue with the Wi-Fi. It's blocking WebSockets, so maybe some features will not be as they should be in the demo. But let's start basically by few slides to explain what this is about. So basically, what we try to achieve is to basically create an open platform inside which everything you may need in order to interact with your data becomes a component that can be plugged easily. Of course, in Python, we have already components. Those modules are something that anyone can create and distribute, and you can just from one link get that component to deliver into your workbench capabilities that could be algorithm, could be anything that someone coded for you and that someone shared for you. The idea of the platform is to say we need a connector for technical computing environments that would be universal in the sense that I will be able to access not only a Python module, but I would be as easily connect to R that runs on the cloud, get R to do something for me, get results back. If I need to continue using Julia, then I will connect to the Julia personality of the remote engine. And in order for this to be seamless, we needed to create a federation layer for data. We want you to be able to say from your Python command line, this is my NumPy matrix, please send it to R. R should receive it seamlessly, become a matrix in R. You do your computation, you get a result, bring it back to your local Python command line, and then if you wish to continue using a Spark cluster, then you push the data to the Scala personality of the same engine and keep going. So basically, we created these Rosetta objects that map your vectors, your metrics, your data frames, whatever you use in these different technical computing environments. We created bridges that can pull and push that type of data. So this is the connectivity as it relates to technical computing environments. Now we wanted something that allow you actually to be able to interact with an infrastructure. Could it be Amazon? Could it be Google Compute Engine? Could it be your local cluster? Or could it be your Raspberry Pi? We would like something that makes infrastructure looks and feels as if it is electricity. You have had this metaphor several times. Everyone, when it comes to cloud computing, they say, yeah, basically utility computing, you plug to that big data center and get computation done. But in order for this to feel and to look and to be accessible like an electricity plug, it takes more than the APIs of a cloud computing infrastructure. It needs some more interaction design to reach this level of seamlessness. So that's what we achieved. So we created on top of the existing infrastructures, the existing clouds, could they be private or public, a common framework that you can talk to from your Python command line, that you can talk to from your browser, from Excel, from anywhere. In order to achieve this integration, federation, when it comes to user interfaces and to interaction, so we wanted something, maybe some of you know of Shiny. Who used Shiny already in the room? Okay, so Shiny allows you to create interactive web applications on top of R functions, on top of R scripts and data. It's people like it because very quickly and without being a web developer, you can create a service and share it with the others. It's not like sharing a function. It's something that can handle scenarios where someone who knows R can deliver something useful to someone who doesn't know R. Think of a bioinformaticians sending something to a biologist. The biologist will be playing with those sliders and looking at those visualization according to the data sets coming from the experiments, and R is hidden. How Shiny works, it's based on what we call reactive programming. So what we wanted here is to take this framework from conceptual point of view and generalize it to any environment. Could it be Python? Could it be Julia? Could it be Mathematica? Whatever tools are accessible through this connector could benefit from this reactive programming framework. And we tried also to make reactive programming as easy as possible. Those who use Shiny would maybe recognize that it's tricky really to write that server code, that client code. It's not for everyone. It's not for statisticians. It's not who are not geeks at the same time. So we try to imagine a way for this reactive programming to be as intuitive, as simple as possible, and to be also uniform. So a consistent, uniform object model that can be sent back and forth to any technical computing environment, a consistent reactive programming model that would allow you to create interactive web applications, interactive services on top of any of those, a consistent framework for infrastructure that makes all of them look the same. Conceptually, they all become like a virtual one consistent cloud, if you wish. We wanted something that makes access to data and storages seamless, basically connectors to whatever storage you may want to access. Could be HDFS, could be S3, could be wherever your data is living. On top of this, we needed to make this platform accessible to any environment, to any language, to any tool you may be using on your local computer. So we created basically all the APIs are in SOAP and RESTful, and we have HTTP APIs that come with clients in VBA, in Java, in Scala, and whatever language you need. You will find something that would allow you to talk to this platform and say, hey, these are my credentials to Amazon. Please create for me an engine for doing computation that understands R and understands Python. So you will be doing this from your client, and forget about the heterogeneity of the clouds, the differences that may exist between Google Compute Engine and EC2 and so on and so forth. We wanted also to make the generation of services on top of functions that you may create in Python or R or Julia as seamless as possible. So basically the platform would allow you to point to functions. Let's say this is a normalization function, and say to the platform, please expose it as a SOAP web service, or expose it to my Excel as a VBA function that I can use from my local Excel spreadsheet. So this is the ambition, and what's the aim? Why we wanted this? The key word here is empowerment. The cloud is something amazing. It's really a bunch of capabilities that data scientists can use and can help them in being more productive than ever. But in order for the cloud to work for everyone, we need to make it accessible. We need to make it user-friendly. We need to create the layers that connect that cloud to the tools that you are already using in a way that is convenient and simple. Empowerment means also that we have to automate everything that can be automated. So Amazon did something amazing by making infrastructure become code, and by making the automation happen when it comes to servers and to storage and to whatever artifacts related to IT. We'd like to complete the picture and get the automation to cover all the spectrum that would be of interest to a data scientist. So this picture shows you this idea of Rosetta Virtual Cloud. Basically, because we have created this broker capable of taking your credentials to any cloud and going to that particular cloud and creating for you these engines with which you can interact from your browser to have a session of Python in your iPad or to have a notebook in your cell phone. So these engines are created by this broker here using your own credentials, which means that this machine is being paid for by you because it's your account. What we do here is be an intermediary or a broker that helps you make this happen without knowing how to use EC2, without knowing how to use GCE. So here you see a user who is talking to this broker, and through this broker is interacting with different public clouds or eventually private clouds. Those here who are familiar with AWS, maybe just a question, who used already EC2? Oh, amazing. Who used already Google's compute engine? A few. Wonderful. So all these things are kind of commonplaces. In order to basically AWS gives you a web console from which you can create your servers, and allocate your storage, and gives you a command line interface that allow you to do exactly the same thing, but in a scripted fashion. You can go even further with scriptability in using the APIs and the SDKs directly. So you can have a Python package from which you ask Amazon to allocate servers and to create for you whatever is needed to store your data. What we want, what RosettaHub is about, we want you to see no borderline anymore between the infrastructure and the data and the code. What I mean by this, we want you to keep control and to have APIs and web consoles and SDKs, but to manipulate artifacts that are meaningful to you, to manipulate engines for data processing, to manipulate data sets of a particular type, of a particular kind. We want you basically to have in your Python command line an object model that maps anything that exists within this virtual RosettaHub cloud. So that you will have an object in Python, which is a machine that maps any machine on any cloud you can access. You will have kind of wrappers that would allow you to automate and program with infrastructure the way you program with data. So another part of the contract is to say what we want is having these engines make the cloud a place for collaboration and real-time interaction between users. So basically, if user one talk to this broker to create this instance of server within which there is this engine that can talk to R and Python, this user wants to collaborate with a colleague on the other side of the globe. All it takes is to tell the broker that there are other users who are entitled to access that same session, that same engine, and then immediately all the users allowed will be accessing the same virtual session. It's like having a Jupyter notebook that will be seen by at the same time by different people who can view and edit. So that's the contract. What we want as well is to use the fact that we have full control on these engines to introduce as much traceability, reproducibility as we can in this platform. So basically, that engine that you allocate and interact with remotely will be capturing every single thing you asked for. So if you talk to the engine and address the Python personality saying, please load this data, we will capture this task. Kind of what Docker does when you create a Docker file. There are steps from going from A to B, and if you have that list of steps, anyone can reproduce what you've done. So we introduced this notion. There is a database that you can look inside and get exactly who did what in that particular engine. And of course, that allow you to replay things. And of course, we use to the maximum of their capabilities, the notion of virtual machine images, Docker images, in order to allow user one to go to this broker, to pull resources using their identifiers, and to get a session in that browser. From that session, you can create results, you can create artifacts, and then tell the broker to create a bundle of those descriptors and share them with anyone. So you can communicate everything related to your environment to any user through this broker by telling which image, which storage has been used, which version of Python, which version of R, and so on and so forth. So let me see if internet works properly. So we are here connecting. So let's. So I went to www.rosettahub.com. That's where the platform lives. This is one of the views because it has also other perspective and other usage scenarios. So you can already join. So the platform is meant to be free. The platform is meant to be a kind of GitHub for data science. GitHub allows you to store your code and share it with anyone and collaborate and create incrementally amazing projects. But what is missing is the real-time dimension. You cannot engage in a session within GitHub like the session you would create using Google Docs. You know, Google Docs is real-time. Jupyter is real-time interaction with a remote engine. All that is not in GitHub. What we want is to say we need another hub where people will be able, using this broker, to create data science infrastructure, to connect to those infrastructures, and to share them, and to basically complement GitHub with something that is open and accessible and free. So let me sign in. Maybe the internet is a bit slow. I can try to switch to another Wi-Fi. Is this one working? Yes. So I'm signing in. Is internet slow for everyone, or maybe? Yeah. So let me see. This is terrible. Okay. This one, and what about this one? It's still loading. Okay, let me probably try to use the old platform. I'm going to elasticr.com. Let's see if it is any better. Okay. So this is the old infrastructure. So let's see how it goes with this one. So let's have a look to what I get when I connect to this portal. Those who are familiar with EC2 would recognize like a similar layout. I have a dashboard that gives me an idea about all the resources I have. So I have currently one machine, and inside that machine I have one container, and inside that container I have one engine. So those engines that can talk R and talk all the other languages. So let me see how it goes when I ask to list my machines. Yeah, I have a machine called DemoCplex running on the cloud of Google, GCE, and it has this capacity. If I would like to create a new one, I will click on launch, and this takes me through a workflow. First step is to choose my infrastructure. Here I'm going to say, okay, I would like another machine on Google Compute Engine. I will choose the keys I have already stored. So anyone can store keys on the infrastructure to allow the infrastructure to act as a broker. The region is already set in the keys. Basically, the keys are related to a particular region. I will say, okay, I would like this to be called demo PyData, for example. And then I can choose any capacity that is available on the cloud of Google. Basically, we expose everything. We expose any capacity that Google has, and we update this according to the evolution of the infrastructure of Google. I will tell the system to let me shut down manually this instance, and that's it. I can review on launch, and that will create a new machine on Google's infrastructure. If I would like to be more specific on how this machine should look like, I will do next. Here at this level, I can tell the platform to attach to the machine any storage I may want to use. It could be attach my HDFS cluster or attach my S3 buckets, and those will become my working directories that I can interact with from Python or R or whatever. So I will keep working locally. Next. At this level, I can tell the platform how what is the topology inside the machine that I would like to work with. The topology here is about containers and engines. Why I would want something complicated? Imagine that you are going to launch a big machine inside which you would like 30 separated environment for your 30 students. And you want everyone to be working independently in a sandboxed context. Then you would say, okay, create 30 containers. And for each container, there will be one engine. And in a later step, you can say, please make these 30 containers shared with this group. So the user, John, will have the first container. User, Nancy, will have the second container. And they will be able to have their proper workbench independently from the others. So here, let's keep the basic mode. Next step, I will be specifying with whom I would like to share. I can do it later, of course, when the machine is running. I can say, okay, I would like, besides the Rosetta engines, I would like to be using RStudio. I would like to be using IPython. I would like VNC to be enabled. So these are extra tools to the platform that can be made accessible. Next, here, because this machine is going to be run on a cloud with my credentials, and potentially I can share it with anyone. I can share it with my students. I need to make sure that the costs are under control. Basically, what can alter the costs apart from the capacity is the data in, data out. So if they upload a terabyte, then the cost will be not the one I have expected for this particular instance. So you can create a threshold. So here we go. And then I will not put a threshold. I will review what I asked for and launch. So this workflow is agnostic to which cloud you are talking to. It will be the same if it is your OpenStack cluster, OpenStack local private cloud. So you see here there is a new machine called demo PyData, which state is pending. It will go from pending to starting, and from starting to running, like this one here. demosiplex. And when it is running, that means I have the possibility to go and have a virtual session with the engine running inside. You see, the machine wanted to starting. I have already one running. I don't know if it is in a good shape. We can wait for the other one, but let me connect to this one and see how it goes. Yeah. So basically, inside this machine, this is a machine I launched yesterday. Within this machine, I have already some views. So you see here, I am interacting. So this is a view of a console. And this is a view of the graphics of the technical computing environment I'm working with. So for instance, here I can create variables by talking to the R personality of the engine. So I will create a variable x equal a norm of 100. I will create a variable y equal 100 element of the normal distribution again, and I will plot x against y. So the plot I have just created actually has been created within a virtual device to which Python can write, to which Julia can write, to which any personality of the engine can write. How is this different from Jupyter when it comes to using different environment? Here, it's only one process that talks to all of them. If I switch to Python, it's going to be Python in the same virtual Java machine that actually has the same memory, and I can get my X and Y directly pushed to Python. I can do. Let's switch to Python. Here we go, and let's create another variable z equal 12, 4, 5. So now I'm interacting with Python. All of this is in the same memory. I would like to, instead of using these views, I will be using, for example, a component that will be like a floating notebook cell. So here we go. I asked for the notebook cell component. Inside this notebook cell component, I can put some R code. I will draw an histogram of X. And if I would like to switch to Python, let me go and grab some matplotlib gallery. Let's take an example from Python. Here we go. Tech. I will take the script and paste it and execute. So now the cell is, So this talked to the personality, the Python personality, to get me this result. At any point in time, I can make this accessible to any user of the platform. I can say share, and I specify the user with whom to share. For example, I will be sharing this with Latifa, and I will give Latifa all the rights to administrate that particular engine I'm sharing with her. So here we go. So Latifa became entitled to access the same thing. So I will open another browser and connect to ElasticR as Latifa. Yeah, here we go. And let me put these side by side. Done. Okay. So you see here that Latifa has one shared engine. So I will go and have a look. That shared engine is the one I have just shared with her. It's a machine called demosiplex that is running the last version of CentOS. And I can, here on the right, you have Latifa. And on the left, you have me. Here we go. So what we will have in the two browsers is access to the same engine, and everything that is done by any of the connected users will be seen and accessible to the others. So let's internet is really terribly slow, but anyway, if it doesn't work. So basically, what this is about, it's about making the tools that you currently use, all of them accessible into one single location. So it's like one-stop shop for data science capabilities and infrastructures. What this is about is making you able to empower, extend your existing code, your existing tools by working with the APIs, and it's coming. It's really slow. You see that on the right, sheet 1 is coming, and when okay, here we go. Notebook cell, yes, coming. Okay, so here we go. And you see every action I have on the right will be seen on the left. Let me change here. N to 300, and you see that it's a collaborative editor. That anything done on the right is similarly accessible on the left. All actions here are broadcasted to all connected users. So there are loads of features in this platform. It's going to be ready in the coming few weeks for its first beta. I advise you to go and register. You will have tokens to run machines on different clouds for free. And later on, you will be able to put your keys inside the platform to create Spark clusters, to create collaboration environment, to access Jupyter or RStudio if you wish. So please go to www.rosettahub.com. register, and let's keep in touch. Thank you very much for your time.